Hey there, welcome to the Sudo show. This is Brandon. Just a little housekeeping. We are changing formats, so we are going to be including a video component. So if you're listening to this on the audio only feed, there will be some things that will be exclusive to the video. However, we will be doing everything possible to ensure that the Sudo show will continue to be consumable as an audio only podcast. Head on over to YouTube and get subscribed. Here's episode 66.
Hello and welcome to the Sudo Show, where business meets open source, a proud member of the Tux Digital Network. My name is Bill, and alongside me today are Brandon and Neil. Gentlemen, how are we doing?
I think I'm doing all right. How about you, Brandon?
I'm doing well. It's been a busy day, and it was a busy September. I know we blew right through that month without getting anything out. It's been a while since we got together, but it's just, I know Bill's been traveling, you've been busy, I've been busy. It just has not worked out. This year has been a really difficult year for us getting things out and to getting things recorded.
I think we can sum it up as life happens, and it's been a roller
Yes,
coaster.
it's been an interesting time. Uh, Bill, how's everything going with you?
I'm doing well. I took some time this summer to relax, take some vacation. Recently, I was out on the West Coast doing some work and got to spend some time in the beautiful Pacific Northwest, one of my favorite parts of the country. I'm actually going back in a couple of weeks. But for now, tonight, I'm here in this amazing space with two awesome podcasters and good friends. And I'm looking forward to seeing where our conversation goes tonight.
Yeah, so the topic of the day is VDI, or virtual desktop infrastructure.
This
And
will be fun.
so whenever this topic comes up, I don't know about the two of you, but there's typically the only solutions that ever come up is a Zen Desktop from Citrix or Horizon from VMware, and of course the usual suspects. The typical go-to in a lot of smaller organizations is Microsoft with just typical with remote desktop.
Microsoft Terminal Services.
Yeah.
In
And
my line of work, I have deployed remote desktop services and VDI in a wide variety of places through a different set of mechanisms. So, in some instances, we're giving users a dedicated instance that belongs to just them. And that's usually when we're talking about graphical software, CAD software, a business executive versus maybe somebody else who just needs a shared instance of applications with other users in that organization. I've done it both ways, and I've used all sorts of different clients to make that connection for those end users to the resources that they need, even Raspberry Pis.
Wait, what? Raspberry Pis? Really?
I have borne witness and helped set up Raspberry Pis as a quick and dirty alternative to an actual managed thin client. Yes, it does work in concept, and for very small deployments, I could see it being practical and available when they're in stock. But for most larger organizations, it becomes a bit cumbersome to manage, and you probably want to use a more managed thin client solution. Of course, Citrix and VMware being the other two popular solutions. However, they don't have to be, because this is where business meets open source. And I feel like we should explore what open source options we have available to us.
Yeah, sure. Right. I think offhand, like I know of. Let's see. There's X to go, and I think No Machine used to be one of these things that was out there.
still is around. I
Yeah, I
I
think they
use
went
No Machine.
proprietary though.
I
Uh,
I still use it for the video editing workstation that I
mm,
use. is actually a virtual desktop. It's a virtual
Whoa.
machine with an NVIDIA graphics card pass through. So
So you're
running.
using that NVEnc and CUDA.
So I'm using No Machine for that because it's the highest performing protocol that works with Linux at this point in time.
Mm-hmm.
And what do you
Yep.
think is the biggest bottleneck in terms of performance when you're looking at a VDI solution? Is it processor utilization? Is it memory overhead? Is it graphics? Is it the network you're running on? Where do you find the bottleneck exists, and what's the best way to kind of work around that?
I would
In
say
my
there's like two big bottlenecks that typically come up. The first bottleneck tends to be something people don't expect, and that is the way rasterization occurs. Um, this actually has a huge impact on everything else. So, like for example, a very simple remote desktop protocol is VNC, or otherwise formerly known as RFB, Remote Frame Buffer. So that protocol is just literally sending pictures over the wire, just frame by frame pictures. That's super slow and expensive because every shot is individual and there is no intelligence about how screen updates occur. Like if you look at a step up, right? You go look at Spice. You look at Spice. One of the key differences between RFB and Spice is that Spice uses video codecs to actually transmit the screen. And that means that I'm going to use a very technical term, partial damage calculation and partial damage transmission. And that means that whenever a modification happens on the screen, instead of having to send a complete update for everything, it only does a partial where the screen actually changed. By design, that is massively more network efficient than doing anything else. And this is why I say, like, this is the thing that has like all kinds of knock-on effects. The second bottleneck tends to be the way that how performant bridging input is to the remote communications protocol. So, for example, you probably, if you're doing something like cloud gaming, because it's a very popular topic in the enthusiast spaces, it's cloud gaming thing. You want absolutely low latency, accurate um, loops for input handling. You want to be able to capture the input from the client, take it, process it, send the response back, and do that as quickly as possible because some games really care about the input lag, and that's a thing that matters. Now, in Office and in a lot of Office cases, this is less important, but it kind of depends, right? If you're doing game development, or if you're doing testing, or if you're doing VFX and production type stuff, that ability to twiddle on a hair trigger can be important. So these are the two bottlenecks you tend to see. The most common open source solution usually tends to be derived either from the X11 protocol or the VNC protocol, RFB. Both of those are highly inefficient at both of these things because they both, while sort of X11 supports partial damage transmissions and stuff like that, in practice it doesn't work because most modern X11 applications don't use the X server to draw the window. They draw it themselves. That's been the case for like the past 15-ish years. And as a consequence of that, there are no network efficiencies when using X11 protocol for transmitting remote desktop stuff. It actually is almost worse than VNC because it is not even optimized for transmitting huge full screen updates all the time. And so you have these kinds of problems that lead to really awkward interactions when it comes to virtual desktop infrastructure. Um, does that make any sense?
I guess it does. So basically, it's not designed in its current state, though, that protocol to scale out particularly well. And Brandon, maybe you have a little bit more insight and knowledge as to kind of what's the break point that you think an organization should look at when they're doing VDI. In the world that I live in the small business, 10, 20, maybe 30 computers, sometimes the initial overhead of VDI might be a little bit too much for that business to swallow. But maybe you have some ideas of where VDI can kind of scale out, knowing the limitations of what X11 can do, and then we'll kind of figure out what that looks like going forward. But maybe you have some experience or knowledge you could lend regarding VDI rollouts or that breakpoint of workstations.
I really haven't done a ton of rollouts recently, but when I was doing VDI a lot, really wasn't necessarily the discussion wasn't necessarily around how many machines is the break point. It was more around does the individual need a powerful workstation, or can they get by with a thin client connecting back into the VDI farm? Is their work highly confidential? So does it need to stay in the do their files need to stay in the data center? There are laptops that essentially boot into a thin client operating system, and they connect back into a VDI session in a data center. And that's so it depends. Like, what's the use case? What are they using? What's the use case for that end user? If the end user is a road warrior, it likely doesn't make sense for them to have a virtual desktop. They're going to need a laptop, and all their files are on their laptop. So of course there's going to be a risk there, but it depends. It's a use case specific thing, and there's no silver bullet on when to start deploying virtual desktop infrastructure. Also, there's two parts to virtual desktop infrastructure. There's the full desktops, and then there's streaming applications, like your full desktop applications. This isn't as common anymore now that more and more and more applications are now web based, versus, aside from Microsoft Office, there isn't a huge uh, collection of desktop applications. I guess the Adobe suite, and others that can be streamed.
I think
With
you tend to see this more when you're looking at high-end developer experiences or creative professional work, where sometimes it may not be cost effective to deliver um, the necessary hardware to a person, uh, in a given circumstance. Maybe they're far away from their normal location, or it's an emergency or whatever. Being able to provision those resources, in the cloud, and then being able to connect to them directly and use it like that is super valuable in a lot of circumstances. I actually want to touch on something that you kind of alluded to. When you said it depends. I think it depends. Like, you also mentioned how streaming applications hasn't is falling out of favor. I think the reason that we see it less now is because it's actually moved to more specialized cases rather than in the more general purpose case. You see it with cloud gaming, for example. You see it with cloud development, video production, those sorts of things. Those you tend to see it because
I see it with
realistically,
fintech quite a bit, where or specialized industries that maybe work with Department of Defense, where you
yeah,
can't have things in a cloud. It's just not within their compliance structure. And that's another instance where VDI shows up more in my world.
yeah, it tends to come in either there's a data regulatory requirement, or there is a cost curve that has to be adhered to of some kind. But again, kind of pulling at this thread a little bit. You're going back a little bit in this. I talked about how the protocols, network efficiencies, and stuff like that. One of the reasons I feel that VDI fell out of favor was that the protocols that were being used were just straight up not efficient over the internet. So you had most of them being some derivative of RFB or using X11 or whatever. And like, as applications have evolved and done things like doing their own drawing, their own widgets, their own, all these other things, that has eliminated a lot of the ways that in the olden times that you could implement tricks and cheats for being able to draw applications efficiently. Like X11 relies on on it being able to draw the widgets for you. And if the toolkit, like say GTK or Qt, is drawing everything itself, then Xlib has no choice but to send the whole bloody thing over as is over the wire, and that's super bad. And
And
VNC's in the same boat. But when you look at Spice, or more commonly, Remote Desktop Protocol (RDP), they're using video codecs. They already have the assumption that you have stuff like this, but then they can work off of things like, hey, the UI doesn't change a whole lot except for when you're doing action specifically in certain paces. So we can just do partial updates, transmit those over the wire, and do other fancy things, and that allows you to do less bandwidth transmission overall and make it more feasible to operate over the internet. And I think the fact that it's taken so long for us to get to that point in commonplace is, I think, a big reason why we haven't seen it so much until now, where things are starting to become interesting again.
Well, Brandon, you also touched upon the fact that there is no silver bullet. And I think it's important for anybody watching this episode to understand that if you're running an organization, you're in charge of IT, you're a system administrator, you're even a help desk tech, you want to avoid that silver bullet mentality, because 9 out of 10 times it just isn't there. And in my years of experience, you really have to tailor your solution to your business need at the time that the need arises. So you may find you implement this and then a couple of years later, it's not the right fit and you have to reboot and retool. That's okay. Just know that if you're thinking about deploying VDI in your infrastructure and in your organization, that there are lots of options available to you, and what you might think is right today may not be right tomorrow. And just be open to that.
I think that that's an important life advice for any technology thing that you do, right? Like, if you look at how technology has evolved over the past 3 decades, right? It's been exponential, rapid clip, whatever kind of phrase you want to use for it's like shoot over the moon and then some, right? Like things have changed so quickly, and that has not slowed down. Things still change quite quickly in all those spaces. And so it's always worth it to bake into your plan whenever you're deploying a technology. How do you reevaluate it on a regular basis, and how do you engage with your supplier slash vendor slash open source project or whatever to convey your needs and desires and to have your needs supported for the long haul? Because if you don't do that, you're going to be in for a world of hurt later. Doesn't really matter what you choose to do.
As you mentioned, Neil, network efficiency, Citrix and with ICA or whatever they're calling it these days, and I can never remember. I'll
They
stick with
change
what
it
I
so
remember.
much.
But anyway, and PC over IP really solved this. Spice does this as well with KVM and over. I'm pretty sure it's more than likely implemented another KVM based solutions that utilize Spice, but that's acting as a broker to the virtual machine, to the display, to the virtual display, not the actual display on the virtual machine. Uh, so it's actually not RDPing into the Windows machine. It's not VNCing directly
It's connecting to the
into the Linux
console
machine.
of the actual virtual machine.
It's connecting to the virtual host, and the virtual host is doing the brokering, which is actually way more efficient, not just on a network from a networking perspective. It's also way more efficient from a CPU cycles, because it still takes up cycles. When you think of RDP, you don't think of it using CPU cycles, but it does. But imagine having 100 RDP sessions on one box, on separate virtual machines, but instead doing it if you broker it, the host handles it, and it's not. It's yeah, there's still 100 sessions, but there isn't 100 separate RDP instances. So it does have a huge impact on how you implement it, and I think that's another reason why PC over IP is so prolific across the virtual desktop space, like whether we're talking high performance computing, like um, for creators and other like oil and gas use cases, like with data science use cases. There's a lot of um, there's a lot of overhead there, and it's something that it is quite. I mean, we brought up Spice. Their Spice is great, but it's way behind. But there's yet to be an alternative. So Spice is currently what's there. And I know in terms of like desktops, like at the desktop level for the desktop environments. I know Katie and GNOME are working on integrating FreeRDP, which is
Yep.
great. And being able to do headless sessions is, from my perspective, a game changer. I'd like to take it up a level and there be a broker if you're doing virtualization, but so it acts
So
more like Spice.
you bring that up, and I find this kind of an amusing conversation because when I worked at Datto years ago, well, it wasn't that long ago, but years ago when I was at Datto at the very beginning of my career, one of the things that we actually developed there was an RDP broker for QEMU and KVM. We called it RDP Mux. It's up on GitHub. The patches are available for being able to plug it into libvirt and QEMU. I never managed to, at the time when I was there, never managed to get the prioritization to get it upstreamed. Someone's interested, feel free to take a look and revive it and do cool things with it. But like, yes, RDP, there has been implementations of RDP in the same way that Spice worked with QEMU and KVM. I would love to see that get integrated into QEMU today. Maybe we'll throw into Brandon will be kind enough to throw into the show notes the RDP Mux project, and people can take a look at it. And if somebody's interested, by all means, like, revive it, make it a thing. I think a lot of people would be super happy about seeing that, and that would like move things further along the curve for using modern contemporary protocols for doing virtual desktops.
Yeah.
I think though, you guys have both brought up the X11 ship that is sailing off into the sunset and is far, far over the horizon at this point. Not quite the VMware horizon. Sorry, I had to throw that in there. But we're past the point where we really should be having a conversation about anything to do with X11 in a modern day deployment. So let's take the X11 piece of paper, let's crumple it into a ball and throw it away. And let's talk about, where does Wayland fit in this? Now, obviously, I know that the Fedora project is really emphasizing that they're moving to Wayland going forward full time, which is great for everybody involved. Tying Wayland into VDI, how do those two interconnect with each other, and what sorts of features could we expect out of VDI or enhancements to VDI leveraging Wayland as part of the solution?
I'm glad you asked this, Bill, because this is actually really, really cool stuff. So, as part of this move to Wayland for the desktop environments, particularly with GNOME and KDE Plasma and anything built on WL roots using that, there's this system called portals. If you're thinking that it's a reference to a certain video game, you are right. But it is also the mechanism in which privileged interactions with a desktop are mediated in such a way that the user always has to deliver consent for it in some form or fashion, whether it's pre-authorized or authorized just in time or whatever. In this system, we have things like an input capture portal. We have things like a screencast portal. But we also have, wait for it, a remote desktop portal. And what that does is it brings the screencast and input capture mechanisms into one interface that is optimized around remote access and allows you to take that in a protocol agnostic way. So basically raw raw graphics buffers, to put it very simply.
Uncompressed?
Yeah. And then it gets passed over, and then either through something like Pipewire or whatever can actually transcode it into a video stream or something else, or it can be passed over to some kind of integrating remote access solution. And then it can do its own encoding and transmit it over the wire with its own protocol. So the remote desktop portal provides you an agnostic way to plug in your own remote access protocol solution that you wish to use. So, for example, if you're using TeamViewer or No Machine or RustDesk, AnyDesk, many of these other things they have implemented or are in the process of implementing using the remote desktop portal to grab the necessary data, in an effective way that they can transform into their own protocol for remote access over the internet. And this is essentially a huge boon for the Linux desktop for remote access, because you're not tying anything to a particular means or method of how remote access is implemented, and you can choose what trade-offs you want to make. So, for example, if you're doing VDI, probably one thing you want to do is also have clipboard interaction. Well, there's a clipboard portal, so you can plug in both the remote desktop and the clipboard portal. If you also want to connect in remote access devices, I don't know if this is here yet, but I think people have been discussing about the idea of having a USB portal and things like that. So you could just plug in, over the network or over some other abstracted means to connect in things like USB devices and storage devices and cameras. And there's also a camera portal, all sorts of things, like to be able to access hardware resources on the computer in a meaningfully system agnostic way. And that's actually really important, because GNOME and KDE Plasma could not be more different internally. In the old days, what you had to do is you had to figure out how each desktop worked and wire in hooks for each one of them. That honestly does not scale. That really does not scale for being able to properly support a Linux desktop experience over the network. So this gives you a simple interface that everyone can work off of, and everyone can be assured that any desktop that implements this API you can use without having to write extra code for. And that's a huge, huge win.
So it sounds like Wayland was built with these types of application deployments in mind. It comes out of the box with the tooling that a developer would need to create the solutions and systems needed to make VDI usable in modern day systems.
I don't know if I agree with your first statement, but what
Yeah.
I will say is that because when Wayland was first being developed, you got to remember it's 15 years old at this point. When Wayland was first being developed, there was very much a thought of like, we got to go back to basics. We got to just do the bare minimum to make things go onto a screen, and we have to fix the fundamental flaw that we have with our current graphics pipeline, which is we can't be assured that the frame makes it to the screen. That was the problem that they tried to solve. Everything after that has been built up of people interacting with these things and saying, this is a shortfall that we need to have closed. This is a gap that needs to be fixed. These are features that we need to have. These are, behaviors that don't make sense in the real world. And all of these have been done as what we call Wayland protocol extensions. And these are layered protocols that are on top of the core Wayland protocol that provide the experience you know today as a Wayland desktop experience, or a Wayland mobile experience, because Plasma Mobile is Wayland as well, or in your cars, IVI, infotainment video informatics. I forget what the phrase is, but IVI is the initialism, and that is also a Wayland-based environment. There is an IVI protocol that goes on top of the core protocol that implements all these things. Now, I know this is a little bit of a tangent. I promise you, it's important. So these protocol layers that are on top are about addressing all these different use cases and handling all these different things. So a protocol that was introduced into Wayland I think it's like called DMA buff or something like that, is direct memory access buffers. And so it gives you a zero copy way, a very highly efficient, because you're not having to mess around with anything, access to the graphics that are being rendered. And you can just scoop that up and put it into whatever else you want. And that is a big difference from what we had in the X11 days, where everything was rasterized by the X11 protocol first before you could get access to it. This lets you step in between, the thing that's like presenting, pipelining it, and rasterization, which is drawing it on screen. Rasterization is drawing it on screen. Being in between those things means you can get the most efficient way to turn that into something that you can get for a highly responsive remote access mechanism.
I think responsiveness and scalability have to go hand in hand when you're talking about VDI, because one system is going to be responsive, 100 systems may not be responsive if you don't design it correctly or if the protocols are working against you. Now, we've talked about performance a bit and we've talked about the underpinnings, but we can't have this conversation without talking about securing those types of RDP sessions. And I know that with the advent of containerization, Podman, Docker, whatever have you, do you guys, either of you, feel like there's a way to kind of tie those two concepts together? Maybe everybody's virtual desktop session is a separate container somewhere on a container host. How does that all look? Do we have any background on that? Do we know where that might be headed? Is there anybody out there who has any experience with this?
Containerization for Linux, I'm going to say it's not there yet.
I am going to agree with Brandon on this, because I have been doing experiments on this for I think the past 2 years. You and I have been like poking at this. It is not easy to do. And also, people aren't really thinking about this, like, to put it bluntly. It is not a use case that people are really thinking about. And it is something that is going to come up over and over again in the near future. But we're still dealing with the fact that we're not over the hump yet to getting into the Wayland world, to getting the more efficient protocol stuff. We don't even, like, one of the other challenges that is currently trying to be worked out is, how do we handle pre-authorization for portals? Because in a mass deployment scenario, you can't have users having to click every time that an access has to be done locally. That's not reasonable. And so we have to come up with a workflow in which we can both balance the security of the environment while being able to support mass deployments, mass provisioning, and mass access. Because, for example, in environments where the computer is not yours, right? Like in a corporate environment or in an education environment where you may need, for example, remote assistance, right? Rustdesk is an example of one of these tools, or Vayon is another one. These tools are designed to be used in a way where, the person in question who owns the controller side of it, they may have different terminology for this, but I'll go with controller as the general term for this. They have the controller side of this. They have to be able to jump in without having to wait for somebody on the other end to click the OK button. And that's a real problem right now. Like, we don't have a solution for that yet. There is a couple of workarounds that are in place. Like, for example, so I played with TeamViewer when they released their Wayland experimental experience. And their recommendation is that your desktop needs to support the ability to remember what you chose. And so one time you need to do it locally. And then every other subsequent time, until you reboot the computer, it will remember that thing and be able to let you access it over and over again. That is a workaround for a problem that we actually do need a solution for. And so these kinds of things have not been yet figured out. And once we get to that point where we can handle things like pre-authorization, mass management of these permissions, things like delegated access, like, once we have those things locked in place, again, then we can talk about containers and things like that, because containers are a largely non-interactive world. And that is where, like, this current story is not there yet. Even on X11 land, it's still not great either. Like, there's other problems.
It's not even.
Yeah,
I'm going to argue it's not even there.
Yeah.
But Neil, I know
Sorry,
you
I
brought
rambled a
up.
bit too much.
I know you brought up all the user permissions and things like that. But with these are headless systems, and so there's not going to be a way to interact with it most of the time. And so that's where I think that doing something that brokers to the virtual display versus attaching to the local system where it creates some sort of either a virtual monitor or whatever. But in this case, I'm like in the case of like what's been done in KVM, what's been done in all the enterprise class VDI solutions, it's brokered. It's brokered to a session that is headless, and frankly, that probably gets around a lot of that. And if we can figure that out in the container world, where there really isn't a way of saying here's a virtual display, here's multiple virtual displays that you can broker to, you really can't do that. The system will likely, the container would likely spin up the Wayland session with a virtual monitor in memory, and that's where it's at. Unless there's been a fundamental change, I don't really see that happening. I think that's where I think this is one of those use cases. I know that I probably have been guilty of this. I don't know if I've been guilty of it on this show or not, but I know I've been guilty about this with just talking with people in general about technology, that everything's going containers. But in this case, I actually do think that virtualization for desktop virtualization is going to remain virtual. It's never going to go containerized, not just because, mostly because of the reasonings I already gave. There's no real good technical way right now to handle the broker, doing a broker to a container display. There really isn't a display, even a virtual one. And also, the vast majority of virtual desktop workloads are going to remain on Windows. They are not going to be Linux. In high performance use cases, there is, of course, the for Linux. Like I know a lot of the animation studios use enterprise Linux for their workstations, and that's not going to change, and even for virtual workstations. But until we can figure out that the way of brokering that without there being some sort of permission access at the local level, there's no way Linux desktops will ever become a containerized solution.
So I've got two counterpoints for you. The first counterpoint is that KDE Plasma supports generating virtual desktops, virtual screens on demand in Quinn. So you can request one and then launch a desktop in it if you'd like.
Yeah.
Actually,
so does
it is
GDM.
so sort of. So the thing is that Quinn can do it basically at any point in time. You can do it for whatever purpose. You can even do it in a local desktop to say, like, if you want to put a window, like if you're doing a presentation and you want to screencast it, you can actually tell KDE Plasma to generate you a screen to put the presentation on, and then the real desktop is never actually sent to, like, say, OBS Studio or whatever. I used it the other day to try out like recording a presentation, and it was actually kind of neat. The other thing is, the real problem that we have right now is that we don't have a way to deal with mediating GPUs into containers. That's actually the real problem. So in the virtual machine world, you have two real choices. You have pass-through and you have paravirtualization. So VirtIO GPUs paravirtualization, and then you have things like VFIO or SRIOV and these various things for pass-through. Because you're able to do these two basic techniques, it becomes a lot easier to do an accelerated desktop. But in containers, you don't have that because you don't have a virtual machine monitor as an intermediary between you and the hardware that can do that. So your only real choice is to have some way to have a MUX or some kind of splitter or mediation mechanism to have access to the GPU device, so that both the host and the container can use the same GPU without taking full ownership of it. Once you have that piece, a lot of this stuff kind of falls by the wayside, and all the other problems are easier to solve. Like the interactivity issue, again, pre-authorization that can be configured in a container. Once you have the ability to do pre-authorization, that problem goes away. Really, the issue is that in order to operate headless with any real performance, you really don't want to be running on the CPU. You want your graphics running on a GPU device, and so there hasn't been interest even in the enterprise space with GPU based workloads, which shocks me because it's really important to have this. There has been no interest that I can see so far. Again, I'm happy to be proven wrong. Brandon, maybe you know something that I don't, but I haven't seen anything in the container world around setting up device mediation. And without that, and without a way to like mux and split up a GPU so that you can have access to it shared between the host and the container, this ain't gonna fly.
I know there's a lot of work with NVIDIA to do that, because there's more than just graphical use cases that
Yeah,
need that.
encoding.
There's
What if
already
you want to do encoding workloads at scale? That's like
there's a
really painful.
yeah. Well, I actually just was talking to a customer about this, a fairly large cable company. Apparently, encoding at scale there is all CPU bound, which made my head explode. But
I know of a very semi indie video streaming platform that they said that the reason that they actually also do CPU based encoding because it is too hard to figure out how to scale GPU based encoding, and that is silly. It should not be hard to do that, but there's just not been a lot of interest or drive into solving this problem because there's just, to be fair, there's been a lot of other problems to solve first, right? Like, and most of the container based workloads are not graphical oriented, not even in the enterprise. Most of them don't care at all. And and we're just now edging towards the cases where GPU based workloads are starting to really matter. And so we're going to have to start thinking about this problem.
I now know what your next GitHub project is going to be, Neil.
You are not committing me to that. I don't know.
I think the only place I would be committing you to is an institution if I am correct here.
It would certainly drive me nuts.
So we've been talking a lot about brokering, and I just wanted to illustrate this. So those who are on the audio, who are listening to the audio only version of this, there's a link in the show notes to the diagram I'm showing, and of course, or you can hop up on YouTube and go to the same timestamp and see this diagram. It's a very simple diagram, and basically, this is how Spice works, and it's very similar for other
It's basically how
protocols.
RDP mux works.
Yeah, it's very very similar to how other protocols work, proprietary or open source. So your user has it authorizes that they want to log into their virtual desktop, and then the broker will proxy the session to the end user, and then the session is a direct connection from the hypervisor that the virtual machine is on to the end user. And typically, and Neil, I'm glad you brought up the GPU question, because sometimes some of these protocols were designed to use the fastest GPU, whether if it's on the client side or server side, or if it's not a GPU, if the CPU in the data center, it will render the image quicker for the desktop. It'll stay in the data center and it won't offload it to the client. Anyway, that I just wanted to make sure that, because sometimes when we talk about these things, we don't sometimes it's hard to visualize, and I wanted to make sure that people understood when we talk about brokering, this is kind of this is super high level of how it really looks, but it does give you an idea of how
And a piece that's missing in your diagram is Virgil, right? Virgil renderer, which gives you the ability to paravirtualize and broker GPU resources.
Yeah, well, Virgil, from based on my current memory, does not work in this specific use case. That it works if you're on your local machine and you're using a local VM. But as far as I'm aware, the last time I attempted to do anything with that over a network, Virgil did not work.
So I know of one provider of virtual desktops infrastructure that's actually using Spice plus Virgil, and they've been contributing to both projects as a result of it. So it definitely can be done over the network. It is additional complications for sure, but like there's been a revitalization into Virgil and stuff. I think I recently saw someone working on a pull request to add VirtIO GPU 3D acceleration support for Windows, which would plug into the Virgil infrastructure and give you the ability to like have paravirtualized graphics.
What is Virgil specifically?
So Virgil is Virtual Graphics Layer, or VIRGL. And originally it was designed to give you the ability to do OpenGL passed through from the guest into the host. But it has been expanded to other protocols, Vulkan, and I think there's some work going on with Direct3D through Angle and stuff like that. But like the idea is when you're using Virgil, you are essentially putting in a dedicated GPU device that is created by the virtual machine hypervisor. So that's VirtIO GPU is the virtual GPU device name from KVM and QEMU and all this other fun stuff. And then that has a driver in the guest. Linux has one built in. Windows is now getting one. See aforementioned pull request. I'm sure we'll link it in the show notes. So if people are morbidly curious, they can go see how a Windows driver is written. Spoiler, it ain't pretty. But you take that and you're able to basically take all the calls that the computer makes and it passes it through to the virtual machine monitor, who then plays it on the host GPU. Now this is where things get interesting. If the host GPU is a real one, which is often the case when you're doing stuff like this, even if you're using Spice as a way to remote into and access it, then you're able to take advantage of locality and efficiency, and then Spice will then just send you the result over the wire. But you could also just transmit the actual commands, the requests, over the wire to your remote machine, and the remote machine would actually run the commands. And so the GPU actions would be done on your computer and not on the other end. These are all things that are possible today with the stuff that we've got. It's just people haven't been putting it all together because it's like we have bigger problems right now. Like the move from X11 to Wayland unlocks so much in terms of efficiency gains and opportunities in terms of stuff like this. Like the virtual thing becomes way nicer in a Wayland environment because the compositing is a first-class aspect of a desktop. And so you don't have this mixture of bitmaps and buffers. Everything is a buffer and a surface, and it can be transmitted efficiently over the across the boundary to wherever it needs to go. And you could also pair it with something like RDP's Remote FX protocol for doing remote app and GPU transmission over the wire. All kinds of things that you can do. Spice has some variations of this, some analogs, some bolt-ons, things like that. But like these are the things that we're not able to do yet because the current way most Linux machines are set up, it doesn't enable an opportunity for this kind of efficiency. There are workarounds, even in an X11 world, right? Like you can have a fully composited X11 session, but you can't intercept you can't do some of the interesting things we were talking about earlier with the portals of being able to grab the buffer before it's rasterized. So you get a lot more out of a Wayland environment, not just for security, but for efficiency, for performance, all these things that, people just, we're just not able to fully take advantage of yet because not everyone's there yet. We're going to get there. And, with Fedora 40, they're talking about, I believe GNOME is considering it. KDE Plasma's got a change proposal out for this. And again, these are things that are coming, and they're going to bring tremendous opportunities for people to build new and exciting ways to do VDI in a way that I think will seriously revitalize the space in a way that we haven't seen in the past decade or so. And your thing about Windows applications, I did not forget you, Brandon, saying that Windows is the primary thing for VDI. With Valve and Codeweaver's investments into Wine and things like that over the past few years, we are increasingly getting to the point where we could even do Windows workloads on Linux, and I'm very excited for that future.
We've had a pretty in-depth conversation regarding VDI in terms of protocols, server-side design, a little bit about clients, and practical use cases. And I think that's important because everybody's got a different use case and everybody's working with a different set of tools. And so I think it's important for you out there that are watching or listening to us to understand that there are snippets and pieces of the VDI that are hopefully useful to you in your everyday practical business use case. But as the days get shorter, the air gets just a little bit colder, do we want to, on the Sudo show, make a prediction that 2024 will be the year of the Linux virtual desktop?
Oh man, you're ballsy, Bill.
Well, it already is in certain industries.
A new day has dawned. Well, everybody, I want to thank you for either watching or listening to this episode of the Sudo show, where business meets open source. Thank you and enjoy the rest of your week.